Just, oh, sorry, Corinne. Thank you for starting the recording. So yes, we are recording. And we're going to just dive in with the last couple of people jump in here. Next Gen Science Standards want us to begin with a phenomenon. All our science inquiry begins with a phenomenon. So I thought it would be just kind of fun to take a phenomenon, which is fruit trees. I pulled a couple of examples out here. You could imagine whatever your favorite fruit is or something that makes it relevant for you, but we're thinking about fruit trees. What do we observe? What do we notice? What are some questions that pop into our minds as we think about fruit trees, as we observe fruit trees, as we travel through our daily life and see different trees in the community? What are some things that might pop into our heads as we think about fruit trees and trees? And one of the questions that might pop into a kid's head, if they're looking at fruit on a tree, what will happen when that fruit ripens? At the moment it pops free and it disconnects from the tree, where will that fruit go? Will it go up in the sky? Will it go down to the ground? Will it just swirl around and float in the air? Will it disappear? What will happen to that fruit and why? So I'm going to give you a second to think about that question and then start typing your responses into the chat. What do you think will happen to the fruit when it disconnects from the tree? And why? For those who are just joining us, we've got an image up of a tree, and we're asking, what happens when a fruit breaks loose from its tree? Where will the fruit go? Down to the ground, up in the sky, will it disappear? And importantly, why? Why do we think that? I see there may be seven or eight people have typed into the chat. I'll give you another minute. What do you think? A couple more people are joining us. All right, what do you think is going to happen to the fruit? And why? Why? Why do you think that? All right, 30 more seconds to type your responses in. I think only half of you have typed a response. Come on, a couple more. There we go. And Eric, what are the responses? What are people saying?
We're getting a lot of good ones, Teresa. We're getting a lot of people have used the vocabulary word gravity. They've been referring to gravity and that it'll fall to the ground. So they're kind of combining that. But we've also had a couple interesting ones about the fruit will die and the animal will get it, will start to decay. So we're sort of thinking about what will happen to it once it leaves the tree. Drop or fall, and some interactions with animals. Squirrels getting it, decompose. Nice, nice. We have a lot of ideas about what's going to happen. So we have a model in our mind. We have something that was helping you to form an idea. Without seeing the tree, without seeing the fruit drop with your own eyes, you were able to describe what happens when that fruit fell loose from the tree. And many of you were able to put in an explanation. The word gravity appeared in a lot of the responses. It was really interesting that you also, some of you went down the road of thinking, now what happens next, right? That's another part of the model. But that model that you had in your head allowed you to see that tree and respond to my prompts and have an ability to describe what happens and also to explain why. Now, how about that model helping you to predict? Thinking about what if. So let's look at this image. There's obviously not to scale. There's a child, and he's got a ball, and let's assume it's a ball, not a balloon. What's going to happen when that child releases that ball? What do you think? You can make a prediction. Now, what about this child? When this child releases the ball, where is it going to go? Now, if you think about some of your students, they might be thinking about down being a relative term to the page or the screen,
So here's a way that you could engage your students. This is a little, not directly modeling, but a little hint around assessment and how we want to see students showing their learning. You want to present them with 2 arguments and see which they agree with. So some of you, when I ask the question, where would this ball go from the child on seemingly on the bottom of the earth? Carlos thinks it's going to go in the same direction that he sees in the image, down toward the bottom of the screen. And Julia says, no, it's going to go toward the earth, right? So if you were doing this with your students, you could ask them to articulate who they agree with, Julia or Carlos, right? The model would allow them to begin to make a prediction. What do you think? Do you agree with Carlos or Julia? Eric, what have we gotten responses?
Still coming in. Let's see. And you can just put C or J. A lot of Julias, 3 votes Julia, 2 votes Carlos so far.
So some people think if this child on the earth, we're over here in North America, maybe he's over here in Australia, if he drops the ball, it might fly away from the earth.
So we've got 3 votes Carlos and everyone else Julia so far. So
very interesting. Anybody who picked Carlos want to share your thinking?
One is taking back Carlos, a misunderstanding. And one question about context. Are we in outer space?
No, this was just meant to model a kid in Europe versus a kid in, say, Australia on different sides of the earth. I did not find a good graphic for it. Graphics are definitely weak on this, but the idea was falling in the same direction that it seemed on the page versus toward the earth. So it might be the graphic might be a little confusing. But this is
John just brought up a point around that too. He mentioned limitations to models, right? Because these
right.
Obviously proportionally very big compared to the earth, right?
Exactly. And that's one of the things we're going to talk about. There are limitations with models, and what do models help us to see and do, and what do they not help us see and do? So here, this model had some weaknesses in terms of the graphics and the context. So, but we could set up an opportunity to have a discussion. So the person who said Carlos could have some clarification in the discussion. Well, I chose Carlos because, and the person who said Julia could answer back, well, I chose Julia because, and maybe in the discussion, they would realize they actually had the same idea. They agreed that gravity would pull the ball toward the earth, right? Using what we used in the earlier model. So that model in their head, the model in our heads about what happens to the fruit tree with the fruit falling toward the earth, and understanding gravity is the force that makes that happen, allows us as adults to look at this and for the most part be able to understand and predict that doesn't matter where you're standing on the earth. If you drop something, all things being equal, it's not a balloon or something, it is going to go toward the earth. So I just wanted to do that as a quick kind of fun warm up to just have us do something with a model that would kind of let us realize we have models in our minds. They're based on experience, and they help us to describe what's happening in the world, to explain why it's happening, and very often to predict things. And that's what we're going to be talking about today. So I'm going to stop for a minute. I just wanted to jump in with that as a warm up while we waited for everybody to get into the meeting and do some quick introductions about who is here. And so I hope that each of you will type your name and your grade and your school into the chat so everyone can see who's here. And we have, very exciting to me, in the registration survey that you all filled out, it looks like almost all of you are teaching some science. And so that is super exciting. And I'm glad to see that. I'm Teresa with Community Resources for Science, and I know most of you or have seen most of you, and I'm so happy to have you join us again today. And our team members, Eric and Corinne, are here too, and we'll have some chances to get to talk a little bit more in breakout rooms. And I don't think Tracy has joined us yet, but John is here. John, I would like to turn it over to you and let you welcome the teachers and share anything you'd like to share.
Yeah, hi everybody. Thank you so much for being here. Thanks for coming after what I know was a long day at work and even a long week already with the rain. So I'm grateful that you're here. I'm also grateful to Teresa and the CRS team. If this is your first time with CRS, you're in for a treat. They are great, super practical things that you can do in class tomorrow even, and they really just have a great concept of both the standards and how we want our kids to engage with science and how we want you to engage with science as well. So I just want to say welcome, and we're glad you're here. Just in terms of housekeeping, we are just keeping track of your attendance on both the chat that you are checking in here. So make sure you check in on the chat, and also by the Zoom login, we have your information there as well. So we will submit your time card automatically. You don't need to worry about that. And if you have any other questions, I'll put my contact information in the chat. Would love to visit your classrooms and see any of this in action. And I know Tracy McManus feels the same way, and we'd love to meet with you, plan with you, support you however we can. So thanks very much.
Awesome. Thank you all for being here and for continuing the momentum and really being the leaders that you are at your school sites and across the district. And I always like to stop and take a moment. I know we want to dive in and we want to do all the work, but it is so important to step back and have that context of why this matters. And there have been two recent reports that have come out that kind of reinforce what we at Community Resources for Science have been advocating for a long time. The National Academies for Science came out with a very robust report maybe about a month ago, really strongly advocating for greater public policy support and funding for science education, and all the way to elementary, which often gets overlooked, as you know. And so we're here to try to support that elementary science teaching, and those of you who might be even 6th, 7th, and 8th in a school that's a K-8 school, we want to support you. And you, all of you, we really want to celebrate you because you are here today. You are building your own capacity, but you're building the capacity for your school site and for your district. And we are going to continue to look for ways to allow you to be leaders and share what you've learned and your experience, your practical in the classroom experience with your fellow teachers who maybe aren't here. Some of them because they're busy, we understand that, but maybe they also aren't here because they're not super excited about teaching science or super comfortable teaching science. And so you're helping to lead the way because it is such a critical matter of equity for your students, and we want to support that. So we'll have fun, we'll share, we'll learn today. And I know many of you said during distance learning last year, one of the things that you learned that was really important was to try to find ways for students to have voice and to be really as active as possible in their learning. And even simple ways of just giving them chances to share their ideas or to write things down is really important. So we want to carry that forward today. So definitely, if you feel the need to share something or stop, do that in chat throughout our session. Feel free to unmute, pop out with questions. We want to hear what you're saying. But how are you feeling right now? Are you the sleepy bunny, the hungry bunny, the eager bunny ready to learn? You're welcome to share that in your chat. You're welcome to just reflect on that for yourself. But we know we've got lots of different kinds of bunnies here with us today, and hopefully we will be meeting your needs. I always am sad when we do the turning the clock back, but I do love getting that extra hour of sleep, and I do find myself having a little bit more energy until it gets dark, and then suddenly the energy's gone. So I'm okay. I'm not sleepy bunny yet, so we're good. So our focus today is on this science and engineering practice of developing and using models. That's a big mouthful, right? And learning, you're all in the business of teaching, right? And that kids are learning and we're all learning. It's really the process of using this practice, of taking the ideas we have in our head, our understanding of how the world works, and testing it, bumping into the world, seeing things, wondering about things, having experiences that are constantly making us revise that model in our head. And better yet, in learning, taking that model that's in our head and making it explicit, making it external, talking about it, sharing it, so that we can continue to revise it. And so I hope that as we go through the day-to-day, you're thinking about why that's important. And when we close at the end of our session today, we'll circle back and talk a little bit and share out why this process of modeling is important. And I think we've seen kind of an example of sometimes where people have a model in their head and they don't revise it, right? We can all think of things when people get one idea and they get stuck on it, and that can really lead to some challenges. So this is a really important process and a part of Next Gen Science Standards and our California Science Standards. So I wanted to sneak in a little bit of review for those of you who've been with us. So I have a little pop quiz before we get going. So just type your answers into the chat. So our first question is, what are the 3 dimensions of California's science standards? We've talked about the 3D, or the 3 aspects, the 3 strands. What's your idea of what the 3 dimensions are? Eric, are we getting some takers, some responses?
Not yet. Coming in, one mentioned the word domain, cross-cutting concepts.
Cross-cutting concepts, woo woo, that's one.
Inquiry.
Inquiry is an important part of it, that's for sure.
Engineering.
Engineering is a part of the standard. That is across all of the standards. Any other ideas? Does this image of a strand of yarn that's woven together refresh your memory?
Speaking to that, patterns came up.
Patterns. So patterns is an example of a cross-cutting concept. So when you see things about 3D teaching, 3D science teaching, it's talking about the 3 dimensions of next generation science standards, which are the standards that California adopted more than 6 years ago, 2013, 14, implementing 2015, but we're still learning. So the first dimension is the scientific and engineering practices. That is, what is it that scientists and engineers do? How do they go about the business of doing science? Asking questions, collecting data, right? These are the practices. Cross-cutting concepts is the second dimension, and thank you, somebody remembered that. And patterns is an example. And the idea of the cross-cutting concepts is it doesn't really matter if you're doing life science or something about space or geology, physics, any aspect of the scientific and engineering world uses some of these key concepts to kind of make sense and fit information together. And so those are things like patterns and scale and structure and function. And we're not going to go through all of them today, but that's one aspect of the standards. And the third dimension is the disciplinary core ideas, or in the old standards, which were just called the topics or the content, right? What we're teaching about. So all of the lessons that you see, all of the things that are aligned to the new standards should in some way identify how they are connecting to each of these 3 dimensions. And you as a teacher will have a picture of how that fits together. And it's lofty stuff. It's going to take years to get there, but it's good to have that framework in your mind so that you are thinking about that strand and that strand woven together to make strong science and inquiry learning. And so these are the practices. And we are today drilling down into that strand, the first dimension of the practices, on one practice, developing and using models. So that's how what we're doing today fits into the bigger world of these standards. So we're going to be looking at that practice of using a model. So what's a phenomenon? NGSS wants us to have our science phenomenon-based. What does that mean? What's a phenomenon? Type it into chat if you have an idea. Any takers?
Not yet, coming in.
What is a phenomenon? If you had to define a phenomenon or give an example of a phenomena.
Something that needs explaining, a natural occurrence.
Ooh, Ooh,
Something that can be explained by science, an event,
nice.
something unheard of before, an observable event, something observed.
Nice. You're on the right track. Thank you. So scientific phenomena, there's a definition there, occurrences in the natural and the human-made world that can be observed and that make us wonder and ask questions.
And here's a little reasoning about why phenomena, Teresa, a curiosity that gets students invested.
Absolutely. That is the core of the idea behind Next Gen Science Standards and our California Science Standards. It's that you start with that curiosity. In the old standards, we walked into class and we said, hi, today, boys and girls, we're going to learn about barn owls. Why would kids care about learning about barn owls or whatever we decided the topic of the day was, right? We want to pique their curiosity. We want to show them something interesting. We want them to begin asking what's going on here. And that's what the science lessons are, the process of beginning to figure out, because then it sticks. What you learn has more relevance because you've actually been curious to try to figure something out, right? So that's the whole idea behind Next Gen Science Standards. And again, I am going to acknowledge for all of you, that is very lofty. It is not easy to do. So it's a big challenge. And that's why, it takes a lot of time and training and thought to be doing it well. And so again, commending you all for being here. So it's challenging. Where can you find resources to support your science teaching? You all should get this one right. Any responses? Nobody.
Oh, yep, we got shouted out right away.
Woo woo. All right.
Oh,
So you
and
want to be sure you've bookmarked our main page. And for those of you who haven't already done it, I would particularly encourage you to bookmark our special page for our Richmond and West Contra Costa teachers, which is this second link here. And you'll get this slide deck and you'll get these all in email. But when you get that, I would really encourage you, bookmark the best resources link there, because every PD we've done with all of our Richmond and West Contra Costa teachers over the last few years is there. You can find the slide decks, the lesson plans, the resources that you need to take a lesson and do it in your classroom. So if you remember something that you did, or you're curious and you're looking for something, these are really robust, ready to go lessons and resources for you.
And Teresa, they're also calling out some district resources.
Yes.
District Online, certainly Mystery Science being adopted by WCC USD, EEI as well at the state level is called out.
Yes. Awesome, all resources. Very good. And the last question I have in my pop quiz is, who wants recognition and prizes anyway? You all do. So we are introducing our Champions of Discovery. Many of you got recognition previously through our Science Superstar program for excellence in teaching. This year, knowing it's a really difficult year bringing teachers back, we want to encourage all of you to do the Champions of Discovery Challenge. There's one challenge every month. It's doing science with your kids. You can use your regular curriculum, the regular lessons, whatever you're already doing, or we're providing some slide decks and some suggestions that you can just take each month from each month's challenge and do with your students. Share back a couple of examples with us. You can share the slides, you can send us an email, whatever works for you. And then do 4, 5, 6 of those challenges, and you're going to earn some prizes and some recognition by the end of the year. So we'll share those links, and I encourage you to do that. Okay, back to modeling now. So we talked about the goal of modeling is to really move our students from that internal, what's in their head, to getting them to put their thinking on paper, to discuss it, to share it out loud, and those models that help them figure out and understand and navigate the world. We want to make them explicit and external and shareable and revisable. And so those of you who are working with TK and K, how many kids walk into school with still some confusion about what's real, what's imaginary, thinking about dragons and dinosaurs, they're still sorting a lot of stuff out. And we want to get those ideas and the things that are bumping around in their head out for them to be able to talk and share about and discuss, and to learn the social emotional skills of being able to listen to each other's ideas and kind of respectfully share some other information, not the don't argue or you're wrong or, but really how do they share and look at the same information, talk about a model that they've built together as a class and evaluate what's missing from that model. What is that model not helping us to understand that we need to add to it? So really having this, making it explicit, shareable, and revisable is what we're going for with this practice. So what is it that models are used to do? They're, as we talked about earlier, defining or describing something. So if we were thinking of those fruit trees, we could have a basic model that just is describing the tree with the fruits on it. But if we're thinking about that tree with the fruit falling to the ground, that model is going to help us explain there's gravity in action and it's pulling that fruit down to the center of the earth. And a model can help us predict and better understand how our world works. And that revising is what we want to be encouraging students to do with that initial model they have. And they do a lesson and they learn stuff. You want to be able to go back and revisit that initial model and help them become explicitly aware of how they're changing things over time. I know a lot of teachers use a class chart or science notebooks to have students at the beginning of an investigation do some observations. So some of them call it OWL. We observe, we wonder, and then as they go through the investigation, what did we learn? What did we learn that now has helped us to have a better understanding of what's happening? So in any lesson that you're doing, you can incorporate some aspect of modeling. You're not going to want to do it every single time, but looking for opportunities to articulate that model in their head at the beginning, and then go back after doing some learning, some investigating, to revise that model, clarify that model. So what is it that models are when NGSS is talking about it? It could be, we often think of a physical model, right? A replica of something, a diagram, a drawing. I doubt very many of your elementary kids are using equations, but that's what they're going to be moving up to in secondary. But anything that I was thinking about this, memes could probably be a model, right? That would be something that's probably missing from this NGSS list, but probably familiar to a lot of your students. So there are ways that are representing something. And I would encourage all of you, it's a separate training that we've done and that we do incorporate in all of them, but science notebooks is a consistent place where you can really be having your students engage in creating models, writing about their models, drawing, going back and revising. So I would encourage you to use that practice of having your students use science notebooks. I think about maybe a third to a half of you indicated you're already using them. So if it's a new practice to you, reach out and let us know, and we'll be happy to share some information to help you get started with using science notebooks. Does anybody have questions about these two ideas? What a model is used for and how we're going to use models, and kind of what a model could be. Anybody have any questions at this point? Nothing coming up in the chat. You can unmute. So I'm going to give you some time in a breakout room to now talk about what modeling in the standards kind of is envisioned in your grade band. So the K through 2s, it's kind of at this more simple level of describing an object, comparing maybe two objects, representing things, talking about the scale or patterns that they see, and maybe developing a model, something that they could draw and then build, for example. And in the 3rd to 5th grade, it's becoming more complex. They're going to be using it to predict a little bit more, test some things like cause and effects, work together as a class to sort of talk about relationships, something being in a system like an ecosystem, rather than just an independent, the one part, but how multiple things fit together in a system. And it's going to get more sophisticated in a way. So I'm going to, Corinne, I don't know if you've put in the link to the slides, the teacher deck, but we're going to have you go into breakout rooms with your grade level, and you have this resource that shows the model at the two different grade bands, and we have a blank slide there. Find the one that's for your grade level, and you can all kind of write on the slide. It's blue, and it just says like kindergarten, how do you use models? So one of the things that we know every time we do these workshops is you're already doing a lot more than you think you are. And it's good to stop and think about what you actually are doing and what your students are actually doing. So in your grade level groups, we're going to give you about 10 minutes to talk about how you're already seeing the use of models in your classroom. Are your students using models to describe or represent real things? Kindergartners are used to playing with model toys and model animals. How are they using that to explain their world? And are any of your students using models to predict things, being able to develop something that would help them think about an if-then scenario? And what types of tools are they using? Are they using mostly physical objects? Are they using drawings, diagrams, sketches? And you can talk about how you're bringing any of this into your teaching practice explicitly, or you can just talk about things that you observe students doing day to day that involve using models to understand the world. So we're going to give you about 10 minutes to go to the grade level groups and talk about these questions on this slide and to share some ideas on the slide in the slide deck. Corinne, have you put the link in?
Yes, I put the link in the chat, so you guys should all see that. It's the last chat that's there is the Google Doc she's talking about. And in a minute, I will open up the breakout rooms and you can select your own breakout room. So if it happens that because of who's here and who's not here today, if you're the only person in your breakout room, feel free to move to a different one. You can do that as well. So you can go up a grade or down or whatever. And there's 2 groups for 3rd grade because we had so many 3rd grade teachers sign up.
Yeah, we want to make sure you have a chance to discuss. And I think we had 10 or 11 or 12 3rd grade teachers. So if you don't mind breaking into 2 groups so that everybody gets to talk a little bit more, that would be great. And I think for the other grades, we had about 4 to 5 people for each grade level. So hopefully that'll work out. If you're in TK or 6th grade or special ed, choose the group that you think is going to be most relevant for you. And we'll give you some prompts, but really it's a chance to talk about modeling in your class with your students right now. What are they doing? Are you doing anything? Or do you see your students using models in some way, in science or not in science? We're going to give you just a little open time to talk about that modeling practice.
So Teresa, it's 3:35 now. When are we going to come back?
I will give you 10 minutes.
Okay.
And we'll give you prompts and we'll pull you back. So
I'm opening up the room now.
Thank you. And I'll stop sharing my screen. Anybody who had something that came up in their conversation that just they thought was really interesting or exciting that you want to share out? Any examples of how kids are already using modeling or how you're already incorporating some use of modeling? Unmute and share with us.
One thing I actually, that reminded me, now that you guys mentioned modeling, it reminded me, we actually, last year we built like a Martian habitat, and we also used like Google SketchUp to model it ahead of time. I forgot I did that. It's just that since you guys mentioned modeling, I said, oh, that's what we did. But we're gonna probably build Martian habitat again this year where they build it to scale. They design it on Google SketchUp first, and that's a free download. And we also make use of stories in our class a lot too. The kids, especially if it's funny and exciting, they really get into it. So we've been doing I always like stories. That's a big thing, especially I guess it depends on what grade I am, what stories are appropriate, but I try to remember the good stories. So
Awesome. Stories are really important. That's an important part of that. Thanks for sharing. And yes, I think you're all doing this in various ways already. And so we're learning just how to make this practice a little bit more scientifically, intentional, and thinking about it, and continuing to elevate that skill. I think of modeling as kind of like this. I found this image for like the scratch off paper. And to me, I think modeling is really this kind of process of we just reveal a little bit, we know a little bit, and we're constantly trying to get more information and learn, and we're revealing a little bit more of the picture about the thing that we're interested in as we go along. And so that's kind of like my mental model to think about what models, the process of using models. And I tried to create for you a model, a simple diagram of sort of what our science standards envision in terms of the progression of teaching. And I think we've talked about it a little bit, that starting with curiosity, that phenomenon, that noticing and wonder, and it reminds me of something. And then picking one of those things, one of those questions to really dig down into and begin to investigate. And as you're doing that investigation, as you're beginning that process, articulating that initial model, I think it might be this because of this. I'm not sure, but this is kind of what I'm thinking, because that helps you decide what investigation to do, right? You have to have some idea of how to investigate and what data you might want to gather. But the really important step is that you then, after you've done that data gathering, after you've had some discussion and thinking about what you've learned, do you need to revise that model? And I know some of you have used sentence frames that I used to think this, but now I think this because, and you can incorporate some of that evidence. And I think this really, if you take nothing else away from today, I hope that you really take away that this practice of modeling is really how you can get your students to be able to become stronger critical thinkers, to use evidence and information and evaluate claims by first articulating what it is they think they know, and then as new information comes along, being able to understand that's not a battle line. It's not about being right or wrong. It's about revealing more and more information and revising that thinking over time. And the social emotional skill that goes into debating and sharing your ideas and listening to others and being willing to change your own thinking. I think we can all see a lot of examples in our world today where that might be missing. And so we really want to teach our students that skill. So I'm going to let us do a quick modeling, just kind of activity, thinking about how this would look in your classroom with your students. We're going to do a quick modeling activity, and then I'm going to give you planning time to go back to your breakout rooms, back to those slides with some links to specific things about your grade level, what a modeling practice at that grade level might look like, and some lessons where you might find that resource. So first, let's just do a little bit of a model of modeling. So if I were to give you this phenomenon of fruit trees and the phenomena of a bunch of fruits, somebody at a different grade might do leaves, right? You could focus on the leaves in these pictures instead of the fruits, depending on your grade level and what you might be thinking about. So thinking about the fruit or the leaves or about trees, what do you notice? What does it make you wonder? Now, normally I would have you set up a science notebook and do that entry, but for today, let's just use the chat. What are things that you notice? What are things that you wonder as you look at the trees, as you look at the leaves, as you think about fruit? What are some of the things that you notice, that you observe, or that you wonder? Just give you a minute or two to type some ideas into the chat. Eric, are there some observations coming through? Did we lose Eric?
Well, some mentioned that they noticed different.
Sorry.
Go ahead, Eric.
Go ahead, Corinne.
Oh, some said different colors, some are different sizes. The leaves are green. There's different shapes. Somebody's wondering how they taste. And maybe if they're seeing different textures.
Branches, so some commonalities among what they're seeing, some
Nice.
patterns.
Nice. So your students might come up with lots of interesting observations and wonderings, and hopefully they will come up with something, a question that is along the lines of an investigation that you actually have planned and want to do. So you might have to kind of, help steer it in that direction when you've got a lesson ready, but you really want to give the opportunity to start with that phenomenon, start with their questioning. So for 4th and 5th graders, they might look at this and do this activity, and you might be focusing on the fruit. And there might be a question that would come out of about the fruit. Why does some fruits only have one big seed and others have a lot of small seeds, like the lemon? And so first, they could then take that question and creating that model would be just creating maybe a sketch of the tree and the fruit and maybe where that tree lives. Is that lemon tree in the desert? Is that lemon tree in a tropical rainforest? What kind of environment is that tree in? That would be kind of a basic way to get that model, and the students making these observations from their model about the tree and the fruit falling to the ground and some of the things you brought up at the beginning, thinking about what happens to that fruit. Animals might eat it. It might decompose. Now we're starting to think about the seeds a little bit. And here's that first explanation they might be starting to form about why the fruits have different kinds of seeds. They might say, I think it might have to do with the types of animals that eat the different types of fruits. So now we have sort of a model, a depiction, a description, and a little bit of an explanation, something that could launch an investigation. And at your grade, there's an engineering challenge for 3rd to 5th grades around seed dispersal. And I think there's a couple of specific lessons that we've shared and in mystery science, so you could very easily see how this could lead to a lesson that would end with an engineering challenge around seed dispersal and different mechanisms for seed dispersal. So that's an example of something you could do with the upper grade students if you're teaching 4th and 5th grade. I wanted us to do a lower level modeling activity. We're just going to do a model activity where we're just doing a descriptive activity. So the students might look at those trees and notice there's many different shapes and types of leaves. They look so different. And they might have a question, are there some ways that all the leaves are the same? So this is where we're going to do our activity, our quick activity. So I hope you all have some leaves with you. I have a couple of different kinds. And we're going to do a quick leaf rubbing activity. So take a piece of paper. If you've never done it before, now's a great time. Sure, all of you have. Take a leaf and put it down under the piece of paper and do a rubbing with a crayon or a colored pencil. And you should get the shape of your leaf on a paper to come through. So do one leaf. And Eric is showing us his fancy camera set up here so we can see his leaves. Eric, have you?
Can they all see that?
I did see it, except that now.
Oops, hold on one sec. Let me bring it back. Digital mic, there we go. Is it there?
I see it.
And so, yeah, you have different leaves. You can sort of pick the one you want. And Teresa's, one easy way is just to open up a piece of paper and drop the leaf inside. I recommend going with the side with the most texture on the top, because when you do the rubbing, so like this one, there's a lot of veining on the leaf in the back here. So slipping that in and then, peeling your crayon certainly all the way, and then just kind of rubbing over it. Give it a few passes, try and hold the leaf steady so that it doesn't move around and you don't get and of course, we're creating now a model of this leaf. And so there's, kind of see that one. I'll go back to this one here, and maybe it's easier to see it this way, just like Teresa shared. But you can see the main stem and some of the veining coming off of that. And now we've got this pictorial model, which is easy to maybe a little more accessible to use.
Nice, thanks, Eric. So if you've done your first leaf, do a second leaf and do the same thing. And let's see what that looks like.
Feel free to put your pieces of art up to the screen and share it that way if you like.
And you can add some describing words. What do you notice about your first leaf? What do you notice about your second leaf? I'm going to give you 1 more minute to finish your leaf rubbing, because we're doing the express adult version. It's a little faster than you would do with your students. And I chose this example because Mystery Science has a mini lesson that is for all the grades. It's got some articulation for different grades around fall colors and tree leaves. So this is something you could pull out of Mystery Science. But is there anyone who has not finished their 2 rubbings? Need another second or 2? Looks like most people that I can see on my screen have done theirs. So are you finding our question was, are there some ways that the leaves are the same? Are there some things that they have that are the same? So has anyone found something on by doing their models of the 2 leaves that is the same about their 2 leaves that they would be willing to share? Anyone willing to unmute and show us your picture and tell us something that you've discovered about the 2 different leaves that is the same?
A line down the middle. They have a midline.
Ah, they both have a midline.
Mine have little lines on the sides.
Nice. So your leaves both have lines. So that could lead to another investigation, right? What is it about what are these lines in the leaves, right? They can help us to understand trees a little bit more. And the role of leaves in keeping the tree alive and healthy. Anybody else?
We've got both leaves are green, so the similar color.
Some color. Yeah. That's a very simple way to engage your younger students in particular, but even older students in making a very basic descriptive model of something to begin to look at it more closely, to maybe label things that you see, and then to begin to be able to compare 2 things, to be able to find ways that they are different and find ways that they are the same. And as we mentioned at the beginning, there are some things that models can't help us understand about leaves. So when we look at our picture, and I look at my picture of the 2 leaves, it can help me get some understanding about leaves, but there are some things this picture can't help me understand about leaves, right? And so that's another important part of modeling through the grades as the students progress and get more adept at using models, is also being able to discuss the limitations of a model. What can the model help us to think about leaves, and in what ways does the model not really help us understand leaves, and then we might need to use a different type of model or have a different experience to learn about.
And Teresa, I might add to that, how might models be, sometimes they can be a little confusing. So when we did the model with the gravity and we had the globe, we had the earth, and we had these really big people. And so putting, in terms of, we were trying to focus on the concept of what would happen to the object as they released it, but it doesn't necessarily, it's not a model meant to talk about size or proportion, right? So we want to think about that as a limitation and a potential place where they could go down a path that might be misleading. So that's another thing to think about as we think about limitations.
Yeah, and also the scale of a model can help us to understand something that might be too small, right? The inside of a molecule, or the inside of something that's so small that we can't see it with our bare eyes, but we could represent it in a large 3-dimensional model. Same thing with space, right? We can take the vastness of our solar system and represent it with some different balls and marbles and things within a small space to get an understanding. So understanding the limitations and the uses of a model are important things to, again, make explicit with your students when you're using them. Talk about, ask them those kind of questions. I'm not going to go into it, but there's also another direction that an exploration starting from looking at the phenomena of trees and leaves and fruit could be thinking about seeds. And I do have a lot of seeds, radish seeds and wheatgrass seeds that I could send you. It's in the exit survey. So if you would like me to mail you some seeds so you could do some seed germination and a similar activity like this with your students, indicate that in the exit survey, and I will send you some seeds, and there are some resources, both from what we've done before, that you could do a simple seed germination activity and incorporate the practice of doing some models. So now we're going to give you some time, as I promised, to go back into your grade level groups and really plan something that you could do with your students that would incorporate the practice of modeling. Now, I know all of you have access to Mystery Science, so I chose Mystery Science to focus on, but I know some of you use FOSS. We have, as I shared, all of those resources and lessons on the CRS website. I heard some of you talking about using EEI, the state's environmental curriculum, which has some great things that you can pull in and augment your teaching. So there's lots of different places you can find a lesson. But here I wanted to pull out and make visible for you within Mystery Science, where this yellow arrow is pointing, they have the planning guide and the next gen alignment. So you can actually look at that document and you can see, if I was a kindergarten teacher wanting to do this kindergarten lesson on plant and animal secrets, I could look at that NGSS document and see what practices are called out in that lesson, and is there an explicit activity that involves making and using models. So I'm going to send you back to your rooms with that same slide deck that we had before, but I am going to show you on that slide deck, there is something else that you have access to. I have to get to that slide deck, so pardon. Oops, wrong thing to share with you. Share. Do you see the shared deck? Is that what I'm showing? Okay, yay. So you can find for your grade level in this deck that you had before, hopefully you found it in your group before, where you found how you were already using models. The next slide in your grade level section has a link to one of the performance expectations in the Next Gen Science Standards. So you can see a really explicit example of how in the standards they envision students at your grade level engaging in the practice of using models. And this top link is the actual performance standard statement. The other link is the evidence statement. It really repeats the same information, but below that there's a little chart and it gives you some examples of, by the end of this grade, this is what it would look like if a student was able to demonstrate this practice. So you may find those a good place to start, just to get a picture in your mind and to talk with your colleagues about, oh, this is what I'm trying to get kindergartners to be able to do, or third graders to be able to do. And then on this slide, I put an example. I went through all of the Mystery Science lessons and tried to pull out at least one example at that grade level where there was a lesson that specifically used the practice of building and using models. And so in this example, there's a circle of seasons unit, lesson 3, why do birds lay eggs in the spring, that according to their alignment document involves the use of the practice of models. So I'm going to give you about about 15 minutes to go back to your grade level group, look at this, and begin to plan, is there one lesson that you could do? And what does this look like at your grade? Something that you could begin to plan and do. And then when we come back in a couple months, you can share with us what you've done. So we're going to send you back to your grade level group.
And Teresa, then do we also want them on the next slide? There's a green slide where they can actually record some of those ideas.
Yes. So if you want to have a shared document to talk about what you might plan on doing, we put this slide in there. It's there for you to use as you collaborate and discuss if you want to share your ideas about how you would teach or what lesson you would like to teach, how you would like to do something involving the practice of using models. I'm going to let you go back to your groups, and then we're going to give you about 15 minutes there, and we'll bring you back for closing. Any questions before you do that?